Welcome guys, so keep solving our physics subject GRE. So 71, basically 71, 72, and 73, there are three similar questions. They are asking about if you have a two level system, and then there's a E2 and a E1, and then their energy difference is so-called epsilon. And ask you about the average number state in the probability E1. So this is the depend on the Boltzmann distribution. So this is the answer. Right. So this is the answer, and so you can times exponential. Exponential. Let me see. I guess it's exponential E1 over KT from the denominator and numerator. So all you have is this. So it's a not plus E1 plus E epsilon over KT. This is minus epsilon because E2 is larger than E1. Okay, so the answer is B. The answer is B. So 72. Somebody tell you that the internal energy of system is this one, and what is the best capacities of the system is given by which of the following expression. So since you already know the energy, so energy is total energy is this. So what you can do is do the differentiation on the respect to t, and then this is the capacitance what you have. So just the direct differentiation, and I think this is easy differentiation, so I don't want to do here. So the answer is A. The answer is A. You just directly do the differentiation. Basically, you do this, and you will have some square term here, and then you do the differentiation respect to this. So the answer is A. Okay. 73. And then which of the following is true entropy? Okay. By the way, the entropy maximum is when t goes to infinity, then it will become kT times log 2, right? Because you will total have two states. So this is the common fact about the Boltzmann the entropy. Okay, so it said, so let me see. The first data increase without limits with t, as impossible that the entropy max is this one. And then B said it decrease with the increasing t, which is violates your physical intuition. C said increase from t to n naught k long to an arbitrary temperature. C is correct. This is one fraction. No, there's no t. It's k times this. And basically, you have n total. You have n naught, so you have n naught k times log 2. So the answer is C. Answer is C. And somebody would say, why you don't know D or E is correct? Remember, the entropy will go to 0 as t goes to 0. So if t goes 0, then D should go to 0. Okay. So that means D is false. And the 74, they say there are two circular hoops as in while hanging on nails in the wall. The mass of X is 4 times the Y, and the diameter of X is also 4 times Y. If the period, the small oscillation of X is T, then what is that? Y is Y. Okay, so remember in 61, we already proved a formula, which is hard to remember, but I suggest that you must remember. So basically, it's this. The period depends on the moment of inertia in m times g LCM. So if you have a hoop, then basically your LCM is just R, and your I is just m R squared. So plug in, you get and this is your results. Basically 2 pi g over R over g. So if X is R the r of x is 4 times than the y. So the period of r should be 2 times as the period of r should be 2 times of y. Should be 2 times of y. So the period x should be 2 times of y. So y should be t over 2, t over 2. So answer is B. Answer is B. 75 say that there's a uranium nucleus decay at rest. Okay, so what don't care about is you just have some massive object which at the rest and become two splits into 2 particles. Okay, and one is M1 is this, M2 is very small, just helium atom. And each decay has the same kinetic energy. Nobody knows. Okay, and the B said that each decay product has the same speed. No. Okay, the reason is that P1 need to be have to be the same as P2, and the things M1 is larger than M2, right? So that means V1 should less than V2. Also, since P1 equals to P2, so the kinetic energy for the first one is just P1 squared divided by 2m1, and the kinetic energy of the second is P2 squared over divided by 2m2. So from this one we know that P1 is less than E1. The kinetic energy is less than kinetic energy of the second particle. Okay, so this is the common expression. See, the decay product need to go to the same direction. If they both go to the same direction, then there's no momentum conservation. The Saurian nucleus has more momentum. Momentum should be the same. Okay, so the E is correct. We already showed that the small mass have the higher kinetic energy. So the answer is E. Okay, 67. The configuration of 3 electrons, 1s, 2s, 3p has which the following value of maximum possible total angular momentum. Okay, so maximum just add one. When somebody asks you about maximum, then you just add all of the kinetic, all of the angular momentum. So you have the 3 electron. So the total angular for 3 electron is 3 over 2. And the 1s means that L equal to 0. 2p means p means L equal to 1. 3p means L equal to 1. So the total orbital momentum is 2. So J is the largest. J is 2 plus 3 to the half. So it's 7 divided by 2. 7 divided by 2. The answer is A. The answer is A. Okay, so 77 says consider heavy nucleus with spin half. The magnitude or ratio of intrinsic magnetic moment of this nucleus to that of the electron is. Okay, so you need to know the magnetic moment is measure of the tendency of object to align itself with a magnetic field. Okay, and so A is impossible, that there's still it must be non-zero. And also, how about B is greater than 1 because the nucleus contains many protons. So your physical intuition tells that if the mass is so if you're heavy, then it's somehow more difficult for you to be aligned. So the answer should be less than 1. Then so the answer is E, less than 1, because the nucleus has mass much larger. So if you are much heavy, then it means that you are hard to be aligned with the magnetic field. But definitely you are still non-zero. So 77 is somehow like a common sense. You need to know. You can know the answer is E. You can know the answer is E. Okay, that's it. I will see you guys in the next video.